The objectives of today's lecture include review the material syllabus, the contract between Professor Ma and the highly motivated students, understand the 6 different property classifications of materials that determine their applicability, understand the 4 components of the discipline of material science and engineering and their interrelationship, understand classification of materials, understand the 4 types of advanced materials. So first, we talk about the syllabus. So this course is required. It means that if you are a mechanical engineering major, and you must take this course and pass this course, otherwise you will not be able to get your degree. Lecture, we will meet in MDH 1032 at 10 o'clock a.m. Monday, Wednesday, Friday. The office hour will be 2 to 3 p.m. Monday, Wednesday, Friday in my office. Material Science and Engineering, Introduction, Callister, 8th edition, Valley 2009, 9th edition, Valley 2014. So this is 2 different versions of textbook will be acceptable. So everything will be posted on the University Global. The course prerequisites include the Chemistry 151 Engineering Chemistry and the ESCI AC 310 Mechanics of Solids. Regarding the course information includes so this course covers material properties, atomic structure and bonding, mechanical failure theory, dislocation, phase diagrams, polymer structure, and ceramics. So it explores the effect of chemistry on molecular structure and physical and mechanical properties of material, and the methods of controlling those properties to attain the desired effect. The course objectives. After completing the course, the students will be able to do the following things. First, the students should understand the basic categories of engineering materials, for example, metals, ceramics, and polymers. And students should be able to understand how material properties are related to material molecular structures. The student should understand binary phase diagrams and transformation diagrams. And students should be able to select materials based on their properties. The tentative topics of this course include course overview and introduction to material science, atomic structure and interatomic bonding, the structure of crystalline solids, imperfection in solids, diffusion, review of mechanical properties of metals and failure criteria, and dislocations and strengthening mechanisms of metals, phase diagrams and phase transformations of metals, applications and processing of metal alloys, and then we talk about ceramics, polymers, and then we talk about corrosion and degradation of materials and other material properties, for example, electrical properties, thermal properties, magnetic properties, optical properties, and economic and environmental and societal issues. And then we talk about assessment methods, and I think this one is very, very important, and you are very, very interested these assessment methods for this course. And we will have 3 exams. The tentative dates are, this is the February 5th, March 4th, and April 1st, and from 11 to 11:50 in MDH Test 32. And we will also have a final exam on May 9th, 8 to 9:50 p.m. In MDH 1032. In addition to these exams, we also have weekly homework given on Fridays and due on upcoming Fridays. Evaluation. The attendance and the participation takes 5%, and homework 15%, exams 15%, the design project 15%, the final exam will be 20%. Final letter grade, 93% or above, and I will give A, 90 to 92% A minus, and so on and so forth. One thing I want to mention is that the highest grade I can give is A. I cannot give anybody A plus. I need to tell you this in advance. Otherwise, some students, some excellent students might talk to me after class, telling me that, asking me why I cannot give him or her the A plus. We only have A. So I want to let you know in advance. And then we talk about the introduction to material science. So materials are probably more deep-seated in our culture than most of us realize. Early civilizations have been designated by the level of materials development. For example, we have Stone Age, Bronze Age, Iron Age. Now, shall we call Silicon Age or Polymer Age? So different people have different opinions. So material science involves investigating the relationships that exist between the structures and properties of materials. Materials engineering is designing and engineering the structure of a material to produce a predetermined set of properties on the basis of structure-property correlations. So the structures at atomic level, we have atomic level or molecule level, atoms or molecules, microscopic and microscopic level. The properties. Properties is a material trait in terms of the kind and the magnitude of response to a specific imposed stimulus. So for example, the mechanical, electrical, thermal, magnetic, optical, and deteriorative. So we have this kind of the properties for materials. So this diagram shows the 4 components and their relationship, and processing determines structures. The structures will give us the desired properties, and the properties will give us the desired performance. And we can see processing, structure, properties, and performance, and they are interrelated. Now we talk about the structure, processing, and properties. The properties depend on the structure. For example, hardness versus the structure of the steel. So here, look at this picture. So here is the hardness of, we use BHN, this is Brinell, the hardness. This is cooling rate. So here, and so this data obtained from this is the from here. Okay, this is with 4 weight percent of this carbon composition, and from figure 11, and so we can see different cooling rate and degree C per second, and will result in different the microstructure, and microstructure will have different hardness. So that means the properties determine property is dependent upon the structure. Also, the processing can change the structure as well. So this is processing on the structure versus cooling rate of the steel. So here is and you can see processing can change the structure and then structure and change the properties. The types of materials. First we talk about metals. The metals are very strong and ductile, and we know that if you have taken mechanics or solids lab, and you will know the difference between this is this cast iron, this is a steel, and this is aluminum, and how they are different from one another. Especially you can see the metals, for example, the cast iron and the steel, they are strong. High thermal and electrical conductivity, we know that, and metals are opaque and also reflective. The second category is polymers and plastics. This is in polymers and plastics, we have covalent bondings. Covalent bondings means that different atoms, they share electrons. So these kind of materials usually they are soft, ductile, low strength, low density, and also they are thermal and electrical insulators, and also they are optically translucent and or this is transparent. The third category of material is ceramics. Ceramics, and they are in ceramics we have ionic, this is bonding, we call refractory material. They are compounds of metallic and non-metallic elements. For example, oxides, carbides, nitrates, and sulfides. So these kind of material, they are brittle, glassy, and elastic, and also they are non-conducting, and that means they are usually insulators. The fourth category of material is composites. Composites is made of 2 or more individual materials, and so this you can see we have 4 different categories of materials: metals, polymers, plastics, ceramics. So these 3 different materials, and they are fundamental materials. The composite materials are the combination of 2 or more. This is fundamental materials, and so they can fundamental materials. You should know from this slide. You should know that we have 3 fundamental materials. Totally, we have 4 different materials. And then this slide shows the objects made of metals and metal alloys. You can see this is the fork, this knife, this is our utensils, and we eat our food with. And this is the scissors. We have this is the micron. These are small gears. This is a bolt and a knot. And so this is a ring, and so this is other metal pieces. So you can see these items, they are made of these metal or metallic metal alloys. So this slide shows objects made of ceramic materials. And so this brick, we have this brick here. And so these bricks are used for constructions of our residential houses or these commercial houses. And so this is a vase, and this is a tea cup, and so this is the plate, and also and here is scissors. These scissors and is made of this is a ceramic. I think these scissors they are used to cut more, for example, cut electrical the wires, and that's the reason they need to use. So this is ceramic the scissors instead of metal scissors. So this slide shows objects made of polymeric materials. We have helmet, and we have these plastic utensils, and we eat food with. We also have this is a balls here, and so this is this small this dice, and also this wheel, and so also this milk bottle or the other this is bottles for other beverages, other fluids. Room temperature density values for various materials. So you can see, so here is metal. We have 4 different categories of materials: metal, ceramic, polymer, and these composites. And we can see here, this is the I have scissor. This is ordinate. This ordinate is this density logarithmic scale. So we can see metal, and you are usually they have higher density, and the composites you have relatively low density. Ceramic is has decent density. Polymer you're low density. We know that. So these metals we have platinum, silver, copper, this iron, steel, titanium, aluminum, along magnesium. So these are commonly used metals. So also this slide shows the comparison of the stiffness, or this is elastic or Young's modulus in Young's modulus. So here is for 4 different materials: metals, ceramics, polymers, along with these composites. So this is the strength, the tensile strength. Comparison of tensile strength among these is 4 different categories of materials: metals, ceramics, polymers, and these composites. Tensile strength, the composites is higher here. People label this one higher than this polymer. We know that polymer is weaker in terms of the strength. And then this comparison of this resistance to fracture, we call the fracture the toughness. So we have metal, we have very high fracture toughness. Composites, and it depends, and they have a very big range from low to very high one. So ceramics, and the ceramics usually they are very brittle, and the fracture toughness is relatively low. The polymer is low usually. So here is the electrical conductivity for different the materials. We know that metals are very good conductors for this electricity. And so this is we know metals, and we also know semiconductors, right? So the semiconductors is a different kind of material that is different kind of material that is between the metal and between this is the ceramic. We have ceramics, and we have polymers, and in this slide we did not label the composites because in terms of electrical conductivity, the composites, and they will depends on this is the materials. The composites can have very various electrical conductivity. So that's the reason people did not list electrical conductivity for composite materials here. Then we talk about material selection criteria. When you select a material, and you need to consider the several you need to consider several things. First one, an in-service conditions and to which the material will be subjected. So this is very, very important. If you you need to pay attention to what kind of in-service material conditions you want this material to be used. And this is very, very important. Otherwise, so this material cannot satisfy these needs, and then you will have trouble. That means this is the components, and so this is the structure, will be failing very, very soon if you do not pay attention to the in-service conditions. Another criteria you need to think about is any deterioration of material properties during operation. So whenever you want to select a material, you need to think about if the current operating conditions can cause any deterioration of this material. If yes, you need to select other material that can withstand these kind of conditions. And otherwise, so the service life of these structures, components made of this material will be questionable. And so the next aspect you need to pay attention to is economics or cost of the fabricated piece. So this is very, very important if you want to have finish a project within the given budget. The material selection process. First, you need to pick application. Right? So this application determine required properties. For example, so properties, we have this kind of properties. We have mechanical, electrical, and thermomagnetic, optical, and deteriorative properties. And so you need to have application. Then you know and what kind of properties and you want these materials to have. So this is our first step. The second step, the properties. If you have the properties already, based on the properties, you can identify the candidate materials or material. So this material, from this material, you need to think about the structure and the composition. And then this material, you need to identify required processing. This is processing and change structure and overall shape. We know that, right? So this is the, for example, casting, sintering, vapor deposition, doping, forming, joining, and annealing. So this is different processes, and they will result in the different material properties, even though we might have a same material, but if we use different processing methods, we might get substantially different resultant material properties. So this one is very, very important. For electrical, so electrical resistivity of copper. So we can, for example, for this one, so this is copper, okay? So this is copper, and this is a nickel, and copper with nickel, the copper with nickel, copper with nickel. So you can see different composition of nickels, and this is how we process the copper, and this will give us totally different electrical resistivity of the copper. So this is for the pure copper, and we have this straight line here. And for this copper with the 3.32 atom percent of nickel, and we have this straight line. This straight line, this straight line, they are totally different, and in terms of electrical resistivity. So we can see based on this slide, based on this figure, and we can see that ending impurity atoms terms here is nickel, and to copper increases resistivity. And we also learned that deforming copper increases resistivity as well. So you can see what the composition and the process, how the composition and process determine the properties. So for thermal properties, here's an example: space shuttle tails. So silicon fiber insulation. We can use the silica fiber insulation offers low heat conduction. We want this is a low heat conduction is desired, and thermal conductivity of copper, it decreases with when you add this zinc. This is thermal. So here, so this one, this from so we want to use the silica fiber insulation. So this is a silica fiber. So magnetic properties, the storage. So this magnetic storage here, and recording medium is magnetized by recording head. So here you can see this is the magnetic storage, and so this is the read head, and this is the V read, and this is read head. So this is the main pole, and here this is recording medium, and this is soft underlayer. So this is a return pole, and this is a flux line. Magnetic permeability versus composition. You can see, okay? You can see if we add 3 atomic percent of silicon, we can make this iron a better recording medium. You can see this magnetic field, and so this magnetization, and so we can see, and the composition matters a lot of this silicon. So regarding optical, this is a transmittance. Optical aluminum oxide may be transparent, translucent, or opaque depending on the material structure. And for example, the single crystal, and for this single crystal, this is transparent. And this is if this is polycrystalline and low porosity, and we have this translucent. If it is opaque, if this is a polycrystalline high porosity, and we have this is this opaque. This is opaque. Deteriorative. Or deteriorative. So the stress and this is salt water, and stress and salt water, and causes cracks. Here. And this is that's called the cracks here. So here is a heat treatment and slows crack speed in salt water. This is a heat treatment. As you can see, crack speed. This is a crack speed. So this is SAS. So this is held at 160 degrees C for 1 hour and before testing. So this is you can see this material is aluminum alloy. You can see this processing heat treatment is also a processing the method. The heat treatment and can improve the deteriorative property of these kind of materials and in this salt water. Up to now, we have talked about the material properties of this is the fundamental materials. Then we talk about some advanced materials. Advanced materials, they are used in high technology applications, and they are typically traditional materials and whose properties have been enhanced. So these include the semiconductors. Semiconductors, as I said, semiconductors, they are different, called semiconductors. They are not conductor, they are not the insulators. They are some special materials that located in between. And so for these semiconductors, the electrical properties are intermediate between the electrical conductors and insulators, as I said, right? So the electrical characteristics of these materials are extremely sensitive to the presence of minute concentrations of impurity atoms, for which the concentrations may be controlled over very special regions. The second category of advanced materials is biomaterials. So biomaterials, they are employed in components implanted into human body and to replace diseased or damaged body parts. So this is very, very important. So these kind of materials, they must have acceptable biocompatibility. Otherwise, they can cause big trouble to the patients. The third category of advanced materials is the smart materials. As the name suggests, the smart, they can do something special. A group of new and state-of-art materials that have a significant influence on many technology. The smart implies that these materials are able to sense changes in their environment and then respond to these changes and in predetermined manners traits found in living organisms containing these sensors and actuators. So you know the difference between sensors and actuators, right? The sensors they are used to get the information from outside the environment. Actuators means that after you get this information and the CPU processes this information, and then the CPU takes some actions to do something and via these actuators. The next advanced materials is nanomaterials. Nanomaterials, they are distinguished on the basis of the dimensions of these structural entities and instead of their chemistry.